Hi, welcome to LeetCode. In this, we will discuss LeetCode problem 3373. Maximize the number of target nodes after connecting trees 2. I have already explained the question number 3372, that is part 1. Okay, you can actually first see that solve the problem, then solve this problem. That will be easy. So now what is the problem statement here? The problem statement is same, that there exist two undirected trees n and m nodes labeled from 0 to n minus 1 and 0 to m minus 1 respectively. And we have 2D integers array edges 1 and edges 2. Edges 1 represent the u and v, like there is an edge between the node u and v for the graph 1 or the tree 1. And similarly for edges 2 represent the u and v similar way for the graph 2 for the second tree. And this is undirected, so you can go to v, v can also go to u, correct? So the node u is target. Here the problem statement is different for the target node, that node u is target to node v if the number of edges on the path from u to v is even. Previous problem, that was like the number of edges between the from u to v is k. Here actually different, that the number of edges between u to v is the even number of edges. Then this will be a target node, and the target node itself is a target, can be, because there is only no edge, so 0 number of edges is even actually, correct? 0 number of edges. Now we have to find out that for return an array of n integers arrays where answer I is the maximum possible number of nodes that are target to node I of the first tree if we had to connect one node from the first tree to the another node in the second tree. Okay, so suppose for this example 1, so this is our graph. Our graph actually look like this. This is actually tree 1 and this is the tree 2. So here actually n is equal to, how many nodes are there? 5. And here n is equal to 8. 8 nodes are there for the tree 2. So we have to return an answer of size 5. What is the first I? Zeroth index, it indicates that how many nodes can be target of this node. So here target means I can connect any edge, any node between tree 1 and tree 2. So suppose I have connected here for this edge, node 0 from tree 1 and node 0 from tree 2. Now how many nodes are there that at even distance? Itself is for 1, okay, and for tree 2 1, how many nodes are there at a distance even? This is odd, this is also odd, this is even, this is even. So 2 nodes are there in the tree 1 that are actually even distance. So that's why I have added this 2 plus 1 for itself. And for from tree 2, how many actually are distance, even distance? So for this is actually odd distance. Here actually it is even, this is also even, this is also even, this is odd, this is odd, this is even, this is even. Now how many are at a even distance? 1 2 3 4 5. So that's why from tree 2 I have added 5. So total is 8. So for this you can check our first index 0, its value is 8. The answer is the example is clear, right? And the problem statement here actually. Now how can actually solve this? So brute force approach, you can actually connect any like all nodes from tree 1 to tree 2. So there will be n into m combination, and then actually check how many nodes are at a even distance from the current index I, correct? This is brute force approach. Now how can I optimize this? Let's see some observation that will be easy to understand this, to solve this problem. So this is, suppose the white color is represent the tree 1, and similarly for this is the tree 2, this white color, okay, both the white color. Now suppose this is our target. I am trying to find out how many, this is our target node, and I am trying to find out how many nodes are there at a even distance from this node, correct? Now I can connect any one of this, any node from this node to this node to this. I can connect this node to this node to this, correct? Now what node actually I have to connect? So suppose first of all from tree 2 you calculate how many nodes are there at a distance, odd distance, and how many nodes are at a even distance. So suppose for this node, how many nodes are there at a odd distance? Only this is the odd distance, so that's the odd distance count is 1. And how many nodes are there at a even distance? 2. Okay, Similarly, for all nodes, actually I will calculate this. You can check for this node how many nodes are at the odd distance, 1, 2. So that's why odd number of odds actually 2 and number of even actually 1 for itself. And similarly for this node also. Okay, this I have calculated. Now I can actually connect any node, correct? So suppose if I connect this edge, then how many actually if I connect this, then how many nodes are actually, it will be actually calculated here at a event distance, that actually number of odds here. Why number of nodes odds in this edge, in this node particular? Because this edge will contribute 1, number of this is actually odd. So if I have to find out the even number of edges, if 1 is already odd, then the remaining number of odds, number of edges will be also odd, correct? This odd plus odd actually we get even, right? So that's why this one is actually contributing odd. So that's why I have to take the odd number of edges, nodes are there, can be at a distance, odd distance from this node, correct? So how many nodes will it will contribute from this? Actually I will contribute as a 2 for this, for if I connect this edge. And from this tree 1, how many nodes are at a distance, even distance? So this will give only 1 itself. So that's why this answer it will be 3. If I connect this edge, that will give us the number of 3 nodes that are at a even distance from this node, correct? Now how can I actually optimize this? So first of all, find out the maximum number of even distance from any node, from this node, suppose from this node. So I find out that okay, maximum number of even distance are 2 from this node. Maximum numbers mean total number of actually nodes at a even distance from this starting node, if this is a starting node, from the tree 2, for the tree 2. Now number of odds nodes will be total number of nodes minus total number of even distance node. So this will give us the 1. This is clear. From tree 1, from tree 2, you can check if I start from this here, from here, how many nodes are at a even distance? Even distance itself 1, and this is the even distance. So that's why the maximum number of even distances is 2, and total number of odds nodes will be 1 itself. So total number of 3 nodes are present. 3 minus 2, I will get 1. So this is clear. Now I can take actually any one of these. Like I can actually take the even also. I can actually make the even also and the odd also. How? Like here actually, if we connect this node, okay, then what will be the value actually I can get? I will take the odd value, because I am adding this node that actually contributing odd value, because the number of edges is 1. So that's why if I then I have to take the number of odd from this node, from this tree 2. So this will give the odd number. Even I can actually take also even number. How? So here actually 2 nodes are possible. They mentioned that at least 2 nodes will be present. So if I connect this edge, if I connect this 2 node by this edge, then you can check this actually contributing 2 edge actually from this target node, 1 for this and 1 for this 2. So this actually even. Then actually I can take the even value from here actually, whatever the node actually have the maximum even value. So that's why I can take the even and odd both, because I have actually 2 node at least. So from this target node actually currently I can, if I add the edge, then I will get the odd value. I can take the odd value from the tree 2, and if I take the another node that actually at a even distance, then I can only take the even value from the tree 2, correct? So that's why how actually, so this is both actually I can take. So what I will choose? I will choose both, whatever the maximum of even value, and whatever the odd value. So whatever the maximum value, I will take that, because I can take the both. I have already explained how I can take. If I add this edge, then I will take the odd value. If I add this edge, then I should take the even value, correct? So that's why I will take the maximum even and odd for every node from the tree 1, because I can actually handle that. So that's why whatever the maximum even and odd from the tree 2, I will take that. So this is one observation. So this part is clear. From the tree 2, what I have to calculate. Now from tree 1 actually what I have to calculate. So I have to find out that how many nodes are there at a distance. odd and even. Okay, first of all calculate that. So suppose this is our the starting node. Okay, so this is the starting node. So this will be at a even distance. I mark that. So this is the odd is at a distance odd. This is also I will mark that. This is odd or even position. If I start from this, this is our starting node. This is our starting node. Now here also I make that this is even distance. This is also even distance. Okay, and also finally I have calculated how many nodes are there at a odd distance and how many nodes are there at even distance. Finally, if I start from here, so you can check if I start from here how many nodes are at a even distance. 1 itself, 2, 3. So that's the even is 3, and odd actually I can get 5 minus 3. It is 2. Got it? So this actually I have actually got these two things. One for the total number of even nodes are present. If I start from here, and how many odd nodes are there. And one thing actually I have checked that which node is present at a odd distance or even distance if we start from this any random node. Okay, now what we'll do, suppose if I start from here, then actually I obviously know that whatever the even distance I will take and whatever the maximum value of odd and even from tree 2, this will take. Okay, suppose 3 plus x. So this is one possible answer for this node. Now I want to calculate suppose for this node. Okay, now how actually can I calculate this for this node? So I know the total number of even is 3 for tree 1. Okay, and total number of odd is 2. Now I will check what is the position of this. Position is this even. So whatever the actually even position is this, this is the node. So this will be ultimately whatever the total number of even actually it possible. It can actually also take that nodes actually for its target node as a target node. You can check if this is a node. Now what can be the node as a target? This node can be target. This node can't be. This node can be. Correct. So that's why you can check 3 nodes are possible to target. Got the logic? Now for this also the same. If it is even position. Now suppose this is our target. This is our target node I want to calculate. So this will be again same for 3 plus x. Now suppose I want to calculate this node. So this is the position is odd distance at present at a odd distance. So whatever the actually node are present at the odd from this node, if I start from this, that will be ultimately the even distance for this node, because this is present at odd distance. You can check. So this is a node. Which node is actually present at even distance? Itself 1 itself. This is 1, so 2. So you can check how many odd nodes are present here. Actually 2 total number of. So that's why whatever the odd is present, that will be ultimately it's even for. It will be even for this current node. Got it? So that's why 2 plus x. X will be constant because I can actually take whatever the odd maximum value or even maximum value from the tree 2. This constant is clear. How you are getting this? Like one time I calculated this, how many total nodes are present at even distance and odd distance, and I have also marked that on each node. Now I will iterate for each node. I will check the current node is at a present or odd distance or even distance. If it is present even distance, then whatever the even node present ultimately in the for the tree 2, that will be our count your target node. Now if it is present at the odd distance for this node, I will check how many odd nodes are present at an odd distance if we start from that node. So that will give us the ultimately the even distance now. Correct? This comes like here. So that will be add into the and push back store into the answer vector. Now go to the actual code. So code, first of all I will build the graph. So I have taken I have calculated how many nodes are there in the tree 1 and tree 2. So this will be added plus 1 because they mentioned that n minus edges are there. So total number of nodes will be n plus 1. So that's why n1 is equal to total number of edges plus 1. Similarly for n2, this is for tree 1, this is for tree 2, and I have added two graph. So adjacent 1 of size n1 and adjacent 2 of n2. So first of all iterate the edges of the first graph, and if for u to v, store v to u also, because this is undirected graph. Similarly for edges 2 for the tree 2, your adjacent 2 I am storing this. Here actually I am storing in the adjacent 1. Got it? Now here actually I have taken this actually not necessary, but I have generalized the function. That's why I have taken this 2 vector for tree 2 also, but tree 2 is not needed to marking, right, that it is present at odd distance or even distance, correct? So but I have generalized the function, that's why I have taken 2 similar type of vector. So here actually I have taken one vector position 1, that actually storing that for each node present at a even distance or odd distance. And similarly for tree 2 I have also taken that. This is actually not needed, so but I have taken this. So even one is, I am calling the DFS function for the tree 1. What actually calculate that how many actually even nodes are present and how many odd nodes are present, and which node are present at a odd distance or even distance. I will mark that. So I will mark in the position 1 vector, and I will get the total number of even nodes are present, or even nodes are present. And similarly, total number of odd nodes will be n1 minus even 1. This will give the, because total number of nodes n1, and whatever the remaining, that will be the odd one. Similarly for even 2, from the tree 2 I will calculate that, and similarly odd 2 will be n2 minus 11 2. Got it? Now I will take what? I will just iterating each node for the tree 1, and will take whatever the maximum even 2 and even 2 and odd 2 for the tree 2. This will be constant, because whatever the maximum I can need to take that, right? I can adjust that. So I'll take the maximum of even and odd, and I will check whatever the current node, each position is actually 1. 1 means even. If it is even, then I will take the even. If it is odd, then what I will do, I will take the odd numbers of nodes, because that will be ultimately even for this current node. So that's why I will check that current node for the tree 1 is equal to 1. Then the total number of even 1 for the tree 1, that will be number of target nodes added into that, else it will be odd 1. Got it? And temp will store that sum, and I will push that into the answer vector, and ultimately return the answer. So here actually I am calling the DFS function that actually checking the total number of nodes present at the event distance, and also the marking that node is present in the event distance or distance. So now is even initially true, because the current node, they have mentioned that the current node itself is a target node. So this is actually event distance 0. So that's why I have taken how many nodes are there. Initially it is 0, like initially it is 1 current node, because I am passing the starting node as a 0, any one of these. Now I will check whatever the is even or not. I will mark that in the position of I. I is the node number level. So if it is true or false, it will mark that. Now if it is not even, so that's why it will check as 0, else it will mark that, right? Now I will go to the neighbor of this current node. So if it is not the parent to handle the loop, so that's why I have added the extra condition. Now I will go to the DFS function. I will call this, and here is passing the j is the next node, and the I is the current parent, adjacent, position method that I have to storing the marking of that at a present distance, odd or even, and the is even not equal to is even. So previously it was true. True mean 1 means it is a even distance. So next time this is the odd distance. So this is actually initially even distance. Now it will be odd distance. Next time it will be again even distance. That's why I have just flip the value. If it is 0, then next time it will be odd 0. Next time it will be 1 means the even, and 1 if it is already even, that time next time it will be odd. So that, got it? How it is getting the flip, and ultimately return the current the number of nodes that are even distance. You can check, I am adding that value. Got it? This is clear. So what is time to this? So you can check, I am just iterating each node only once here, big of n, and similarly for here also big of n2, here is n1 for n2, and here also I am just iterating n1. So that's the time study will be n1 or big of n, linear time velocity. Time velocity is clear. And space velocity, we have taken the adjacent vector, that will be n1 plus n2, and any other things we are taking position 1, position 2, again it will be n1 plus n2. Any other thing taking, we are adjusting answer vector, we have to return that should not be calculated. Any other thing, no. So that's why time velocity will be big of 2n n1 plus 2n2. This will be again linear time velocity big of n. Got it? Space velocity also time velocity clear. If you like this message, please like the video. I think this is the easiest way we can solve this problem. If you have any other approach, you can comment on that. That will help for the others also. Thank you.